Hello, everyone, and welcome to today's session of Virtually Golden. Thank you for joining us today. My name's Annie with Golden United. Just a little bit of housekeeping. First, if you have any questions for the presenter during the session, just use the little mute/unmute button at the bottom left-hand corner of your screen. And then once you're done asking your question, just make sure to mute yourself again so that we don't get any background noise. Also, you can use the chat feature if you don't have a microphone or if you prefer to use that. Other than that, a little bit of a heads up about our upcoming session on Thursday. Thursday's session on April 30th is actually a video tour of Golden, presented by Stacy Fowler. It's going to be a little bit longer than our normal sessions are, so plan to book about an hour, closer to an hour than 30 minutes. It's going to be kind of a piece of Golden history moving forward with a video tour and some short little interviews with various people about the current coronavirus pandemic. And once it's all said and done, the Golden Chamber, Golden History Museum, and Golden Civic Foundation will all be sharing that as well. So we'll be able to have a little piece of history with us. So be sure and book a little bit longer for Thursday's presentation. And then next week, Tuesday, May 5th, is actually our last Virtually Golden session. So plan to join us then as well. We'll have Bill Roby and Paul Haseman talking about Golden's railroads for our very last session next Tuesday. And with that, I'm going to hand it over to Kathy Smith, who's been spearheading these sessions, to introduce today's speaker. Kathy?
Thanks, Annie. Happy today to have Donna Anderson with us to give us a geology lesson about Golden. Donna never met a rock she didn't like. She has over 40 years of geologic experience and 20 years in academia at mines, including research and teaching. She has a PhD in geology from mines and is an active member in a number of professional organizations. Locally, she's a graduate of the 2014 Leadership Golden class, and she's currently writing a book with co-author Paul Haseman called Golden Rocks, The Geology and Mining History of Golden, Colorado. And their book should be finished by the end of this year. Looking forward to it. Take it away.
Thank you, Kathy. Good afternoon, all, and thanks for having me back. Hopefully I'll not let you down with this talk. This time I'm going to talk about the role that geology plays in shaping Golden's landscape. And before I start, I'm pretty sensitive to the fact that a lot of you probably have met a lot of rocks you didn't like, so that's okay. But I just want you to know I'm aiming this at an audience that's not geologists, so don't despair. If there's anything technical, I'll try to explain it in passing. So I wanted to first talk about, what is a landscape, since I've got that in the title, and what does geology have to do with that? Basically, a landscape is the visible features of something. In this particular case, it's an area of the countryside or the land. And a natural landscape is made of landforms, mountains, hills, plains, including lakes, streams, the soils, and natural vegetation, all features of what we know as natural landscapes. Well, geology includes landforms, mountains, hills, plains, plateaus, etc., the basic bones of a landscape. And all of those things are formed or shaped by geologic processes over geologic time. And through this talk, I'm going to talk about that whole deep time concept. And you'll find me throwing around millions of years like that was nothing, but that's just what geologists do that. Also, a big part of geology is figuring out how today's landscape, as well as ancient or yesterday's landscapes, came about. So we'll talk a little bit about that too. When you come to Golden, there's really 4 features that really hit you that form our landscape. And on the map on the right here, I have them labeled. There's the Front Range with the M at Mount Zion, the Golden Valley, North and South Table Mountain with Castle Rock being prominent on South Table Mountain. And then Clear Creek basically cuts straight across all these landforms and creates its own valley. If you look at my two photo panel views, one is viewing west, and you can see the mountains of the Front Range, and there's a canyon of Clear Creek kind of off to the center right, and then the Golden Valley is in the middle. If you take that east view, you see the Golden Valley in the foreground. Clear Creek kind of cuts through and separates the North and South Table Mountains. So that's kind of how the whole thing sets up. It's something that everybody can observe. So why is geology so important in this? Well, what I've done here is there's two maps side by side, the same base map. The one you just saw on the left with the topography, the Front Range, Golden Valley, Table Mountains, Clear Creek, etc. And then on the right is mapped with the same map, but in colors. And those colors are geologic rock units of various types and ages. So if you look at the Front Range, which is one of our main features on the west, you see it's all colored gray. And that's because it's a same kind of rock. It's granite and gneiss that is extremely old and highly metamorphosed. We'll talk about that in a minute. Then you see the Golden Valley between North and South Table Mountain, and it has some black lines going down this side with blue and green stripes, and then it gets kind of this yellowish color. Well, those are all various types of rock formations. They each have their own age. The oldest are on the west, and then it gets younger going toward Table Mountains. And that's what kind of makes up the Golden Valley, the softer rocks of these sedimentary features. Then you look at North and South Table Mountain, you notice that this brown color is a ring around both of those. And that's because that brown rock happens to be a rock type called basalt that is forming the cap rock on North Table and South Table Mountain. And then Clear Creek, cutting across all these features, has kind of a lot of yellow colors, and it's just kind of an interesting feature separating North and South Table Mountain. So basically, the map of Golden, the geologic map of Golden, directly matches all the landforms we have in Golden. And that's one of the reasons I say that geology basically shapes the Golden landscape. We'll explore that a little more. So how does geology shape something? Without going into a whole course on geology, basically, there's a lot of processes that are geologic processes. We can break down rocks by chemical action. Rocks actually do rust. They become red, and that's basically oxidation. They mechanically alter. They get eroded. They get then transported and then put back down. It's called deposition by water, wind, ice, and gravity, just like a rock fall would be gravity. They get cooked. I mentioned that the gray rocks on the west side of town and Front Range are metamorphic. Well, you can get everything from what I call rare to well-done metamorphic rocks. And what I would say is those Precambrian rocks on the Front Range are overdone. You can also melt stuff. And what we see, what we're more familiar with melting is volcanism. And I guess in a kind of a gross way, you might consider that when melt gets vomited up, it's lava that runs across the landscape. You can also get uplift, like in mountain building. And now we're getting into a little more esoteric things. But to a geologist, the big drivers in all of this are what we call tectonic forces and climate change, which is kind of like an atmospheric force over time. Just to be clear, a tectonic force is on the scale of what you might understand as continental drift, where continents are drifting around as crustal plates. And if you imagine them smashing into each other, those are the kind of forces that we're talking about. They're huge, and they take a long time to manifest themselves. And all of these form or shape a landscape. So in considering what I would talk about today, I had to realistically say we only have 10 or so minutes to do something, and I could tell a lot of stories. So what I finally decided on was the most iconic part of the Golden landscape are North and South Table Mountains. When you go back in the history of the settlers, as kind of shown here, this 1869 sketch of Castle Rock and South Table Mountain, that's what captured everybody's imagination. It's the first thing the settlers talk about is the Table Mountains. You go out to downtown Denver, you can see the Table Mountains. They're iconic, and they're so iconic, they formed the logo for the city of Golden. So it's actually a combination of two features, the Table Mountains and Clear Creek. So we'll go ahead and kind of build a story on that. Basically though, there's two parts to the story. And what I'll do is first tell you about the rock layers that underlay North and South Table Mountain, the cap rocks, and then the rocks that form the slopes. And then we're going to talk about how Clear Creek formed those two mountains. So kind of taking a little bit of a virtual field trip here, say we're up kind of on Mount Zion looking down on Golden. This is a Google Earth image that I tilted. You see Clear Creek here in the center separating South Table Mountain, the flat top here, the flat top of North Table Mountain. And then you see this thing I've called Ralston Dike. That's where asphalt paving has a quarry that's mining basalt rock for construction material today. What I've done is I've taken that same geologic map with a few more details and draped it across that 3D image. So here now we see that ugly kind of brown color that surrounds North Table Mountain, same color surrounding South Table Mountain. That is basalt. And that is, those are lava flows that basically came from the Ralston area where it's marked RB. And the slopes of North and South Table Mountain are kind of a funny green color. That's the Denver Formation. And that's the other layers that underlie the basalts for the most part. There's one flow we'll talk about here that's kind of in the middle of all the sedimentary rocks. So that's kind of how we'll set up the geology. We'll first talk about the lava flows. So the lava flows on North and South Table Mountain, the brown color here on that 3D tilted image, there's 4 of them that are recognized. Number 1 is here. This is about where my cursor is, the Table Mountain trailhead, where you go up that steep part of the ramp trail to North Table. 2, 3, and 4 are all kind of stuck together in one big mass, and that's what forms all the cliffs on the very top of North Table Mountain and South Table Mountain. It turns out only flows 3 and 4 are recognized on South Table Mountain, and flow 3 actually goes all the way to the bottom of Green Mountain. So flow 3, it all came out of this ancient volcano that was over at Ralston Dike. If you fill in the land surface, the flows came out, flowed across a flattish surface, came down through Golden, kind of in the white band showing here, and flowed. One went to about here, 2 is very local, 3 went all the way to Green Mountain, and 4 kind of stuck and finishes here on South Table Mountain. So at the time these flows happened, everything was connected. There was no Golden Valley. There was a mountain front, but it was actually running about down Illinois Street. And that's what I've tried to show you here in this little 3-dimensional sketch I made around 65 million years ago, what it might have looked like. There's a volcano at Ralston Dike, and it was kind of spewing flows across what's now our city of Golden. And this steep mountain front was actually a boundary on the west, and that would be running down Illinois Street from north to south in today's geography. Well, kind of interestingly, there's been some recent age dating of the basalt flows on North Table Mountain, and it turns out that flow number 1, and here's that steep trail going on the west side of mountains that you hike up to. Flow number 1 is 66.5 million years old. Flows 2, which is out of sight, 3 and 4 are around 65 million years old. So that actually is pretty cool data to a geologist. It really pins down what's going on. So we've talked about the lava flows. So let's talk about them now in context with the Denver Formation, which underlies the cap rocks. So here we have on the upper left a picture of Castle Rock. This is where the Lubon Trail is at the end of 19th Street. You can walk up here and get these views. You see the Castle Rock is made of flow 4 and flow 3. They're kind of irregular boundaries. And then below this dash yellow line marking the contact or boundary between lava and this underlying stuff, which are sedimentary rocks, kind of slightly tilted sandstones, siltstones, and shales of the Denver Formation. This is another view of the Lubon Trail area on the right side. Again, flow 4 is at the top, flow 3 is at the bottom. And here's the Denver Formation, the shrubby slope, but then there's this little lens right here. And that is a river channel where the channel bottom used to be kind of looking down, convex up. And then it's filled with sandstone and conglomerate. So the Denver Formation in general has this kind of aspect. It's full of little channels where the water flowed and deposited the coarset sediment when it stopped. But on the sides, you have the finer stuff, like over by Castle Rock. As it spilled out on the floodplain, it deposited the shales and finer grained sands. Another cool thing about the Denver Formation and the South Table Mountain, it was a real favorite collecting place by Arthur Lakes and his students in the 1870s and 1880s. Now, Arthur Lakes was famous to paleontologists for a lot of reasons. He discovered the first dinosaurs at Dinosaur Ridge. He was the first professor of geology at Colorado School of Mines. And South Table Mountain was one of his favorite places to take himself, friends, and students to go looking for fossils. And some of them were pretty important. This Tyrannosaurus rex tooth, which is here shown below this, where my cursor is on the lower right, was found by one of Lake's students in 1874. And it was sent to the Yale Peabody Museum at the time, and it sat there for over 150 years unrecognized. Well, it turned out it's the first Tyrannosaurus rex tooth found in the United States, probably in North America. It wasn't recognized as such until about the late 1999 or so. They also found lots of plants. Palm, here's a great one in the Peabody collections of a palm tree that has very noticeable, identifiable leaves. So it turns out South Table Mountain's pretty famous in the paleontology world, as well as the guys who like to look at volcanism, which is kind of interesting and brings us to the next cool thing about South and North Table Mountain. And that is preserved in the rocks in those two mountains are the evidence, the position where the asteroid hit that killed all the dinosaurs lies. This, you may know this event as the KT boundary. In 2000, a committee renamed it to the KPG boundary, but we'll just stick to what everybody's used to. But that's when an asteroid hit the Yucatan Peninsula of Mexico about 66 million years ago. That's rather precisely dated anymore. It's 66 million plus or minus 40,000 years, which is awfully precise in the geologic record. But you probably didn't know that the KT boundary in North America was first described on South Table Mountain. And here is a group of geologists, of course, out there on the KT boundary over by Denver West, where it's been researched, all the fossils have been collected. This gentleman is Kirk Johnson, who's now at the Smithsonian. He's standing about the position of the KT boundary. Basically below this are all dinosaurs and plants that are typical of the Cretaceous. And above this, where these people are standing, there are no more dinosaurs. So that T-Rex tooth would have been found in this position, and above here is all mammals. So the KT boundary was a mass extinction event due to this asteroid hit that radically changed the Earth, its climate and animal fauna life. Also, it has not been excavated on North Table Mountain, but what these age dates tell us from flow 1 to flows 3 and 4 is that somewhere between flow 1 and the cap rocks is the KT boundary, the 66 million year old event layer that marks a change in the mass extinction time. So that's kind of cool when you're walking up North Table next time through, there's a little hill here, but here's the water tank for reference. So once you get right above the water tank and you get into this slope, somewhere in that slope is where the dinosaurs ate it. Kind of nice, huh? You bet you didn't know that. So just recapping, 66 to 65 million years ago, Golden was right at the foot of the uplifting Rocky Mountains, which probably meant there were a lot of earthquakes. Interestingly, it was pretty much still at sea level. It was periodically covered by lava flows coming from Ralston Dike, which could be rather exciting at times because they're pretty thick. It was mostly a tropical to subtropical rainforest, as shown here on the right in a picture from the book Ancient Denvers by Kirk Johnson and Bob Reynolds. And then it got fried by an asteroid impact at 66 million years. It killed the dinosaurs and 75% of all the rest of the species on Earth. The rainforest, here on the right, burned to a crisp. The food supply was gone. Everything that relied on it died, and just a few organisms kind of made it past that event. And those organisms were tiny mammals and birds that just kind of managed to live on the ground as opposed to being in the canopy of trees, which didn't exist anymore. So they survived to kind of become the radiation of mammals and birds that we see today. So as I was thinking about this, I try to bring it back to the human idea. And I had to include that this wouldn't really have been a great time to live in Golden. I wouldn't have wanted to be on vacation here at 66 million years ago. But things did get better. And so what we will do, because we are geologists, is we can time travel and hop around all we want. We're going to fast forward to about 5 million years ago and talk about how the Table Mountains became two. So to do that, we need to talk about Clear Creek. And we need to make some observations about Clear Creek Canyon. If you ever have stood around and looked at the mountains, this is kind of interesting. So on the top panorama, I show here's Mount Zion with the M. You see kind of a dash line that I drew along the flank down toward Clear Creek Canyon. Well, that's kind of a nice sloping surface that if you project it across to the north toward Mount Galbraith, makes another kind of gentle sloping surface. And if you look below here, what I did is I went over on North Table Mountain and stood there thinking about this while I was hiking and looked off to the west. And you can see, this is Mount Zion. You see that sloping surface come down, and it's about at the elevation projected as the top of North Table Mountain, similar elevations today. And it kind of makes its turn and goes back up to the north. It looks like a broad valley. Well, then you look at the canyon of Clear Creek, and man, this inner canyon is a V-shaped. It's really steep. If you've ever been in Clear Creek Canyon, you know that is a very steep canyon. And that is actually known as what is called the inner gorge. Like you've heard the inner gorge of the Grand Canyon. Well, we have the inner gorge of Clear Creek Canyon, and that's this big, deep chasm. That's about 600 feet from the projected surface to the bottom of this today's Clear Creek at the mouth. We'll keep that in mind. And let's take the view now looking toward the east at the Table Mountains. And we're going to do the same exercise. You can definitely see that the elevation of North Table Mountain projects straight across to the elevation of South Table Mountain. That one doesn't require too much imagination. The canyon isn't quite as steep. It's a little more gentle on the south side by South Table and a little steeper on the North Table side. And that's not too surprising considering the softer sedimentary rocks here versus the canyon that has the really hard old metamorphic rocks. So this is a little more eroded out. But the elevation from the top of this projected surface to Clear Creek is 600 feet. So we have two canyons across the valley that are the same depth. And the elevation of the top of North and South Table Mountain is about the same as the elevation of that upper surface here showing back on the Front Range view. So, you know, it doesn't take too much imagination to realize that Clear Creek cut these two canyons at the same time. And that's a real important point. That Clear Creek is basically responsible for the golden landscape we see today. So as it turns out, about 5 million years ago, the entire Western US was uplifted. You know, I said earlier that in 66 million years ago, we were at sea level. Well, we stayed there a long time until in the 5 million year range. This uplift started. And what happened is rivers and streams got reborn. The gradients increased and down cutting started. And Clear Creek was one of these streams that started cutting down again through the Front Range and eventually the Table Mountain lava flows. Once it got stuck in its canyon, and here's a picture, say at 5 million years in the block diagram on the surface, you see my rendition of Clear Creek. And here's the lava flows sitting there waiting to be eroded as Clear Creek shot out of the Front Range and kind of started to cut down into those hard flows. Once it did that, it got locked into the canyon. It could not get out of the canyon. And that's a common pattern in the Western US and in the Colorado Plateau Front Range in particular, is you see a lot of these streams that go right across everything, like Split Mountain at Dinosaur National Monument, the Paradox Valley, there's a river there that goes across all the geologic landforms, and everybody's like, what's this? Well, turned out they all have a common history of busting through, eroding the hard rock, and once they got that, they got locked in. And that's what I'm showing on this 500,000 million year landscape, is the Clear Creek had pretty much separated North and South Table Mountain sometime in about the last million years. There's another part to this story. It's like, so you just uplifted and the rivers were faster, but there was another part to the story, and that is the climate got much colder over the last 5 to 2 million years, and even the last million years, and glaciers formed in the upper part of the Clear Creek drainage. We know from regional information that up to 12 separate glacial episodes occurred all over the Rocky Mountains in the last 2 million years, but our best record in the Front Range is for the last 500,000 years. So what I did is I gave you kind of a picture on the lower right here of, again, a Google Earth image looking back from, here's Golden, South and North Table Mountain, and then Clear Creek's kind of winding through its inner gorge up to this white circle that I call the glaciers of Clear Creek. This is where the glaciers formed and advanced in retreat at least 4 times in the last 500 years. And if you ever drive up to the intersection of US 40 and I-70, you can see little moundy hills. Those are the ends of the glaciers from the last ice age, which was ended about 18,000 years ago. So those glaciers pretty much filled Loveland Ski Area, went over to Winter Park, and basically ice was filling this part of the Rocky Mountains for the last million years episodically. So we have ice, and you go, okay, cool, we got ice, so what happens to ice to form a canyon? Well, it melts. When the glacial episodes stop, the glaciers melt. And when the glaciers melt, that is a lot of water. So it brings us to the last chapter of Clear Creek and Golden, and that is what I'll call glacial floods. So every time the glaciers melted away, there were enormous amounts of runoff. That runoff eroded that inner canyon, the inner gorge, and the canyon between North and South Table Mountains. And it's hard to imagine what this was, but of course a geologist that likes this stuff figured that out. A guy named Vic Baker, who's a really famous quaternary geologist and specializes in paleo floods, ancient floods. He went out to the gravel pits over by Carves on the east side of Table Mountains and measured the cobbles and boulders, how big they were, and did what's called a hydraulic analysis to figure out the amount of discharge, volume of water it would have taken to transport those cobbles down from Idaho Springs, basically. So not only did you have water running through the canyon, you have cobbles and boulders being transported and then deposited in the gravel pits near Carves. So he calculated that that glacial flood flow would have to have been about or more than 50,000 cubic feet per second. And that's hard to imagine. So I thought I would plot the historic flows in Clear Creek from 1911 to the present in this bottom graph. And you see where the arrow points to the peak historic flow, which was in September 1933, I think, well, the spring of 33, 5890 CFS, which is an order of magnitude lower than the glacial flood flow. So you've got to imagine the wall of water that would have jetted down the Clear Creek Canyon, eroding as it went. It gets to the mouth of Clear Creek and Golden, and it's going so fast, it starts to spread out, but it still jets right through the Table Mountains, carrying cobbles and boulders which you can view over in the Armory building, because they are built from the rocks, from the gravel pits near the core. So if you want to see how big those things were, go have coffee when we can do that again, and see how big those cobbles are, and imagine those coming out of Clear Creek, and figuring you not want to go swimming during that time. So Clear Creek, a big deal. So what we just did in a few minutes is we talked about the rock layers that made up Table Mountains. They were sedimentary rocks formed by rivers running next to a mountain front about 66 million years ago. Episodically, there was lava from a small volcano at Ralston Dyke covering the landscape over and over. They probably flowed down river channels and then spread out across the landscape then. And then at one point in this time, an asteroid hit in the Yucatan and caused forest fires and climate changing that basically radically changed plant and animal life on Earth, wiping out 75% of the known species at the time, including the dinosaurs. So that was kind of amazing. And then we fast forwarded about 60 million years of Earth history and found out that Clear Creek, mostly through erosion, shaped the final landscape we see today. And glacial floods played a very essential role in shaping that landscape. So climate change was a major player in that whole thing. And in essence, North and South Table Mountains are erosional remnants. And the Golden Valley is another part of that erosion story. And you know, the landscape we see today was probably set up about 500,000 years ago. If you were there with Woolly Rambus walking around, you would have probably recognized just about everything we could see today. So that's my story, and I'm sticking to it. And I want to thank you, audience, and I want to also thank Golden United for allowing me the pleasure of doing this. I could talk for hours, but you'd go crazy. And when this gets on YouTube, there's a bunch of references I have that have used for this talk. If you want to dive deeper into any of this material, I will highlight one book in particular by Keith Meldal called The Rough-Hewn Land, a Geologic Journey from California to the Rocky Mountains. It has many chapters. Each chapter is a neat story. It's very oriented toward the effects of continental drift, those tectonic forces. And it's a good read. It's really fun. My sister, who's not a geologist and tolerates it because I am a geologist, she liked it. So I think that's a good recommendation, and it's available on Amazon if you're interested. And with that, I will stop talking and answer any questions that you might have. Thank you.
Wonderful, thank you, Donna. If you have any questions, use the mute/unmute button at the bottom left-hand corner of your screen, and feel free to go ahead and dive in.
Donna, this is Kermit.
Hey, Kermit.
Do you have any idea how tall those foothills, the mountain front was at 66 million years ago? Are they size of the Rocky Mountains now, or much lower? Or?
That's a great question, Kermit, and I've wondered about that myself. And in my sketch, I made them as high as today's, but I have no data on that. And that's certainly a good question. If you just look at the size of the pebbles in the Denver Formation, which probably came off the rising Rocky Mountains to the west, they're not that big. They're not as big as the cobbles that came out of Clear Creek Canyon during the glacial flood. So, you know, maybe it's hard to say. It's just, it's a very good question. I don't know of anybody that's actually gone and tried to figure that out.
We have a question. Go ahead.
We were wondering, or I was wondering, if the situation with Boulder Canyon and the Clear Creek coming down in that particular area was similar to what happened around Golden.
Yes, so basically what's unique about both the Bear Creek drainage down in Morrison, the Clear Creek drainage, and then the Boulder Creek drainage is they all tap into the continental divide. So they had that ice sheet climate change signature. So basically the answer there is yes. They are similar because they tapped into the glacial melts when they happened. The thing about Boulder is, so Golden, when you look at the two Table Mountains and the whole Front Range from Colorado Springs up to Wyoming, what's unique about Golden is it has those Table Mountains that are preserved by the volcanic cap rock. That is unique landscape along the Front Range. And I think what happened is it really focused the flows coming down Clear Creek. So they couldn't exactly spread out when they hit Golden, but when they got to the east side, man, they just spread gravel, cobbles, and boulders all over the place. It's kind of a unique setup in that regard. But generally, the answer to your question is, yeah, Boulder's very similar.
Thank you.
Cool.
I must have worn you all down.
I have a question. Could you repeat the name of that book that you had mentioned?
Yes, and it's in my references. When it gets posted on YouTube, you can look for it. But the author's name is Meldahl, Melddahl, Keith Meldahl, and it's Rough Hewn Land. And if you just put that in an Amazon, it'll come up that way. I really enjoyed that book.
Great, thank you very much.
Yeah.
Okay, I have another question. I am surprised to hear that there were volcanoes. And is there still volcanic activity in that area?
No, it's old, it's long dead, which is good for us. So it was erupting 65 to 66 million years ago, and as geologic goes, it's pretty short-lived. That's about 1 million years of time. There were other volcanic eruptions that are, evidence for those are down near Castle Rock that are around 46 million years old and came from around volcanoes that still haven't been found up near Mount Princeton. But all that stuff's long, long dormant, except over by, there's been a little volcano over by, along I-70 near Dot Cerro. There was a little volcano that erupted and flowed across what's now I-70 if you go by there. And that was about 4,000 years ago, but nothing in the Front Range.
Very interesting. Thank you.
So Donna, do you have a good explanation of that little anomalously young lava on Lycan Peak?
No, I have, so here's my take on it, Kermit. So what Kermit's referring to is the same people that did the recent age dating on the volcanic flows, found a very geologically young date on the top of North Table Mountain of about 55 million years. And that kind of got everybody stirred up because that wasn't in the known picture. And I have a philosophy. It's like there's things you know, and there's things you don't know, and there's things you think you know. And that was in one of those think you know problems where, oh, we thought we knew everything, but new data comes out and then you're like, oh, So it's certainly possible that there were some flows. I have to tell you, the complicated part of the story is that the mountains we know now, plus what's on top of Table Mountain, was buried in about 3,000 feet of sediment. And that all got stripped off. I kind of fast forwarded through that part of the story. And during that time, as I said, there was a lot of volcanism. And I think it's very, very possible that there's some things we don't understand about the volcanic history, ancient volcanic history. And those dates are telling us something, but I don't think we've come to a good explanation yet.
This is John again. I had a question. Were the Appalachian Mountains contrived or built similar to how the Rocky Mountains came about?
They were a bit different. They were actually the collision of Europe and North American plates in the Devonian. Well, actually long ago, 300 million years ago plus. So they're a continental collision, and the Rocky Mountains are actually an odd plate tectonic phenomena. It's an oceanic plate to continent collision with some weird twists in it that I don't want to get into because it's getting way deep in the weeds for most people. So if you read Keith Meldal's book, he will talk a lot about that, but they're a bit different.
We're getting that book. Thank you so much.
Wonderful. Do we have any other questions today? Okay, if not, thank you all so much for joining us today. Just so you know, we have 2 more sessions left in our Virtually Golden series. One this coming Thursday with Stacy Fowler. Stacy's going to be doing a virtual tour of Golden. It's actually pre-recorded. You'll want to go ahead and book out a little bit longer than our normal sessions for Thursday's session. It'll be about an hour long, but it should be really interesting and definitely a piece of Golden history during this coronavirus pandemic. So be sure and keep an eye out for that this coming Thursday at noon. And then our very last Virtually Golden session is on Tuesday, May 5th. And we're going to be talking about Golden's railroads with Paul Haseman and Bill Roby. So thank you so much for joining us. If you missed any part of this presentation or any of our other presentations that you're interested in sharing with friends or family, you can find it on our YouTube channel, which is linked on goldenunited.org. Thank you so much. And with that, I think we're done today, unless Kathy has anything else to wrap up with.
No, thank you, Annie, and thank you, Donna, for a really interesting talk.
All right, thank you all so much and enjoy the rest of your day. Bye-bye.